Welcome back from spring break, everyone. Hopefully everyone did something good over break. I'm going to talk about the midterm today, about assignment 4, and then on functions if my computer behaves here. Alright, hopefully we're up now. So just going to go through the midterm questions, what I kind of hope to see in your results. So right now you should see your grades for everything you've done in this class on D2L. So if you haven't taken a look at that, please go do so now. You should also see a final calculated grade section, so that will show you what your grades are for everything that we've done in class here. I'm not sure if that showed up on your view. I can't confirm that, but there should be something down at the bottom. It's like a little final calculated grade thing. Does anybody see that? You see it? Okay. Okay, good. So any questions about grades, feel free to stay after class. But anyway, I'm just going to run through the questions really quick here. Again, if you should be able to look at your results as well. You'll have to look at it in Lockdown browser, but aside from that, you can look at it. So if you are looking at it at the same time that I'm looking at it, they are going to be out of order. Questions are randomized, so I'll just go through them as I see them. So language of programming in C, pretty straightforward. What can we store in a float or a double? It could be interchangeable. We can store decimal numbers. What kind of data can we store in a char? So we can store character, letter, anything like that if you would have said something like that. So every statement must be followed by a semicolon. So when we want to use a while loop and when we want to use a for loop. So we use a while loop when we think do something until a condition is true. We say for is iterate over range. So we can accomplish just remember we can accomplish everything we can with a while loop with a for loop and everything we can with a for loop with a while loop. It's just the only thing that for loop would give us over a while loop is it does allow us to easily iterate every single time, and it's usually used when we want to do something a number of times. So I think everyone did really well in that question. So for this question, so each of these individual operators does have a name, but for this question I was hoping that you would give me the name of all of these operators. So these are a certain class of operators. These are, you could say, relational or comparison operators. If you did go through and just name every single one of them, I probably did give you half a point. But I don't know if I did that for sure for everyone, so let me know if I didn't give you the half a point for naming off all of them. So to get an individual random number, we just say rand. That's all you needed for that one. So command line editors, so we've mostly worked with nano, but you also should have named like vim or vi, or some of the other editors that we might have briefly talked about. So what statement do we need to use in order to use printf and scanf? So we need to say include stdio.h. If you would have just said stdio.h, should have given you a point still. What kind of data can we store in an int? What I really wanted to see was whole number. That was really important that you said whole number. If you would have said something like integer, I probably accepted it. But whole number is the correct answer. Remember, if we try and store a decimal number inside of an integer, we do drop the decimal component of that number and just store the whole number component of that number inside of the integer. So for 3 data types, we've talked about int, float, char. Could have said double instead, or you could have said something like this. As long as you name you've named 3 types that we've talked about in class, that's fine. So these operators are basic arithmetic operators. If you said something like math operators, I either gave you partial credit or full credit. I don't recall exactly what I did, but the correct answer is basic arithmetic operators. So the highlighted component right here, so this controls padding and precision. So remember, this on the left side of the decimal is padding. So padding, precision, and then on the right side of the decimal is precision. So remember that padding is the total width of this number. So if we said, let's say we said 4, it's going to print 1, 2, 3, 4 wide. And if the number is smaller than the actual number width is, it's just going to be ignored. But let's say we said something greater, like 5, means we're just going to print an extra space on the left side of this number when we print it out. And then with precision, we're going to print 2 decimals to the right. So when this prints off, it'll say 10.10. If we didn't control this at all, our number would print with the default of 6 decimal places. So we'd say 10.1 and then 5 more zeros. So it's just important to remember that this right here, in between the percent and the F, controls padding and precision. So the 2 ways we can control the flow of our program, what I was really looking for was if statements and switch statements. But it's true that you can also control the flow of the program with loops, kind of. So if you put like if statement and for loop, I probably gave you maybe like 0.75 or something like that. What I was really looking for was if statements and switch statements, because those are the specifically control flow statements that we have. So difference between equals and equality. So equals assigns value, and then double equals tests equality. Remember, we use double equal signs in if statements. Anywhere we need to use a condition, and we use a single equal sign to say, like, let's say we have int a, we can assign a equals 10 or something like that. So command we use to compile our code, we say gcc. Pretty much, I don't think anybody got that wrong. This part right here is called the format string. So inside the format string, there are format identifiers. So format string, and then each individual component is format identifier. So if you said something like what this actually does, like said integer or something like that, I should have given you half a point. If I didn't, again, let me know. These operators are called compound arithmetic operators. So in addition to just doing the addition, subtraction, multiplication, or division, they store the result inside of the left hand. So compound arithmetic operators. Just remember, if maybe a little bit out of practice, normally if we wanted to add something to a, we'd have to say a equals a plus 10. But with a compound operator, remember we can shorten that to say a plus equals 10. So just remember if you forgot that. And then finally, these operators are called logical operators. The book refers to them as Boolean operators quite a bit, I think. So if you said either of those, I should have given you 100%. Otherwise, again, if you listed out what they were, I probably gave you a half a point. Again, if I didn't, let me know and I will update that. So any questions about any of these questions? Anything you want me to talk more about? All right, then. So the programming assignment, where did I put that at? It's probably, I didn't post anywhere. Let me find it here. So this was our assignment. We needed to create a program which generates a random number, prompt the user for a number repeatedly until they guess it correctly, and so on and so forth. So I'll just go through and show you what I did in my code. So important things here. make sure that when we are seeding our random number generator, we're doing it with the time. So I saw this a lot where there was no random number seed, and it theoretically works. The only problem is if you don't seed the random number generator with the time, or if you seed the random number generator with any other literal number, what's going to happen is you're always going to get the same sequence of random numbers generated. So if I was to do this, I'd probably get, I don't know exactly what the default value is, but I would run this program multiple times and I'd always get 8. And that kind of, if we don't seed the program with seed the random number generator with a new value every time the program's run, and that kind of eliminates the purpose of having this kind of guessing game. So you need to seed that with a different number every single time. And in this case, it just happens to be time. So if you didn't do that, I took off probably 1 point. So this is the correct expression to generate the random number. Remember that we need to say ran mod 10 plus 1. So ran mod 10 will give us any number between 0 and 9. And then if we say plus 1, it will take that up to 1 through 10. So I saw a lot of this actually. I think I saw more of this than anything. Was this actually evaluates to 11, so you're getting numbers between 0 and 10, which isn't correct. You need to get numbers between 1 and 10. So, and the modulus operator is of higher precedence, so this should execute before, so this right here should execute before this addition statement here. A modulus precedence is the same precedence as multiplication or division, because again, it's basically just doing a division, getting the remainder, so it has the same precedence. So then I set it up like this. So before you enter your loop, you need to read in what their guess is. And before you enter the loop, you also, again, need to generate that number and store it. So once you enter the loop, let's say they guessed it correctly immediately, their guess would equal number, so this body wouldn't execute, and you'd continue executing right down here. If their guess wasn't correct, we'd print this. We'd increment the count. Remember, we have to keep track of the number of times they've guessed something, so we can print out our conditional responses later down in the bottom. And then we'd read the guess again. And if the guess wasn't right, we'd continue this loop until the guess did equal the number that we generated up here. So remember, the number that we're testing our guess against is the number we generated with that random expression. So finally, that will be right, and we'll come down here. So with 1, so we just test if it's 1, it'll say you are an insane guesser. And the way that I did it, I don't think I saw anybody else do it like this, so I'll kind of talk about this a little bit more. So one of the things that I saw a lot were people doing things like this. So count is less than 4 and count is greater than 1. So the thing is, like, this is completely redundant to do the second part right here. So the reason that is because we're using else if statements. So remember, if any of these conditions are true, let's say this condition is true, since we're using else if statements and else statements, the rest of the statements are completely disregarded. So if the count did in fact equal 1, we'd execute this single block, and then we continue on executing right down here at the bottom. So just thinking about this, let's say we had a count of 5, so it took the user 5 tries to guess it correctly. So we go here, count, or 5 is not equal to 1, nope. 5 is not less than 4, so nope. We come down here, we say count is less than 8, so 5 is less than 8, and then it will print you are an average guesser. So it's just a very simple way to combine the, I should say it's a thing that's worth knowing, to combine the logic of else ifs and combine the logic of these tests. So if you're doing something like this, if you have like an and condition like this, and let's say you're only using if statements, so you have a single if statement every single time, and you're doing like something and something, just remember that you have to test all of the conditions even if they're false, so it's just extra operations that don't really need to ever take place, and you have to test all of these conditions, even though you only really need to do it as many times as you have, as so long as you haven't found the correct answer. But regardless of what you did, if you got the correct answer, if you printed the correct conditional responses, it should have given you full credit. So, and then at the very end, we just need to print out the number of tries it took for you to guess it correctly. So that was it for the midterm programming assignment. Any questions or anything else you wanted me to cover on that? All right then. So finally, we're going to talk about assignment 4, right? Yeah. So for that, I don't think I'm going to go through all of them, but I'm going to go through some of the main ones. I'm going to show you how I set up the menu, and then I'm probably going to do, we'll go through and we'll do triangle, and we'll do sum probably. Later on, I will post the full source code that I use to implement my example, but the one that I use does use functions, which we'll be starting to talk about this week. So once I post that, you'll have to wait until the end of the week for us to really understand what's going on, because it uses functions. So on that note, so first things first, we need to have choice, and we need to read into choice. Or, well, first I guess we need to print the menu. So this was just our general setup. I'm going to skip most of the options just so we don't spend so much time on it. So we'll say 0 is exit, and we'll say 1 is sum, and we'll say 2 is triangle. So then we need to read into choice. We say while choice is not equal to 0, we're going to run this. So inside this while loop, you could either use switch statements or if statements. Either way works just fine. I'd choose to use if statements because just a little bit cleaner when you're running the code formatter, or if somebody else is reading it. It does make a little bit more sense. Choice equals 1. So inside that, we'll have a variable called sum. One thing we haven't talked about much yet is the importance of setting our variables equal to 0 before we use them. So I won't go into it in much detail, but one of the things you can run into that I noticed that did happen a little bit is if you have variables that you are not initializing to 0, sometimes under maybe let's say 10% of the time, it's going to actually give that variable a value, the system is, and this is going to be a random value. So if you don't initialize it to 0, sometimes it'll work, but the problem is sometimes it won't. So what you need to always do when you use a variable for the first time is you need to set that variable equal to 0. So don't forget to do that. If you are running into random errors that don't really make any sense, just make sure you're setting your variables equal to 0 the first time you're using them, because that's one of the source of random errors that don't really make any sense. So let's go through and do this. So we need to have a number to read into, and I'll use a do while loop. Didn't have to. There's a couple different ways you could do this. So let's do the scanf %i num. I'll leave off the prompts just because I don't really care right now. And then we'll say wow num not equal to 0, because remember when the user inputs 0, the loop stops running. So we'll say sum plus equals num. And finally we'll say sum is %i, and we'll give it the sum to print. I had to return 0 down here to remove that error. So 10, 20, 30. We can see that that does print out the sum. So in order to change that to do the running sum, we would have had to take this and put it inside here instead. Could have added a couple more statements. Again, it didn't matter if you use a do while or a while loop. Either one works just fine. So this time it'll just show us what the running sum is every single time because we put that printf statement inside of the while loop. So that should have been pretty straightforward. So I'm going to go over here for the triangle, and I'm just going to have the pseudocode right next to us so we can just take that and convert it into C code. So our choice for our triangle is number 2, so we'll just say else if choice equals 2. And we'll need to prompt the user for the height. Move our variables up to the top. And then we need to start building our loops, I think. We need to have 2 variables. We need to have I and j, or whatever variables you want, but those are our inner indexes and outer indexes. So we say for I equals height. So we're going from the height to 0. So we say I equals height. And we say I is greater than or equal to 0. I'm not sure if I think it's greater than or equal to. I don't remember for sure. But we can come back and change that later once we figure it out for sure. And then since we're going from our bigger number to our 0, which is our smaller number, we need to decrement I instead of increment it. So we need to say minus minus I. So inside of this, we have 2 loops as well. So we have one loop that prints the space and one loop that prints the stars. So we say for, we're going from 0 to the outer index. So the outer index in this case is I. So there's the outer loop, which is this loop right here, and there's the inner loops inside there. There can be multiple inner loops if we wanted to. And there is, in fact, in this case. So this would be considered an inner loop right here. So inner loop, and the entire thing is the outer loop. So we go and we say j equals 0, and then j is less than I, and then increment j. And then all we do is, I don't remember if we need a single space or a double space in this case, but again, we can come back later once we've gone through this and change that later. So it's worth noting for the second loop, we can go ahead and reuse this j again, because since this loop is run in its entirety, we can just go ahead and reuse that index. But we couldn't, let's say we wanted to use I instead, we couldn't reuse that index because that index is storing the value for the outer loop, which hasn't finished running yet. And if we change the outer index, it's going to mess up our loop. So we can reuse j because this for loop is completed running and we don't need to save the value of j. So what we'll say is j equals 0, and then j is less than, well, let's go back here really quick. So you could do a couple different things here. You could do this calculation right here in line, and I'll do that first. So I'll say height minus I, which is our outer index, and that works perfectly fine. But it's a little bit cluttered there. You might not want to do that. So you could have another variable. Let's put that over here. Let's say diff for difference. And you could say diff equals height minus I, and then put that right there instead. Just maybe a little bit more readable, a little less cluttered, whatever you choose. Either way works. And then inside this loop, we need to go ahead and print our stars. Don't remember exactly which side the star needs to be on, but we'll come back again and figure that out later. So basically, it's important to remember that this outer loop right here is going to run once for each row of the triangle, and the inner loop right here, both of the inner loops, I should say, are going to be what's actually printing the individual spaces and stars. So after we've ran the inner loop, both of the inner loops once the outer loop has run once, we need to print a new line at the end. So just \n. And that's all I'm going to do for right now. So close that out, run it. Let's try 5. Look at that, it came out all right. 1, 2, 3, 4, 5. So there you go. That's how you kind of interpret that code if you had problems interpreting it. Just for future reference, that's kind of how I would interpret what I'm writing there. Now, ideally, you'd either equalize this a little bit more, where you'd have a new line here and a new line here, but it's good enough for now. So is there anything else you wanted me to talk more about? I can cover any of these if you want me to, but just for the sake of time, I won't if nobody is very interested. But was there any that you wanted me to talk more about or kind of show you how I did it? Yeah.
The outline's very useful.
Yeah, that's a good one. We should do that one too, because that one's a tricky one. So it's really important to just think of these cases down here. So I'm going to do it kind of I'll do it the compact way first. So let's go up to our menu. This is kind of how you should have gone about writing this program. So right now I have a few options completed. I don't have all of the options completed, but I have a few of them, and my program's working pretty well. So at this point, what you probably should have done is you should have copied it, assignment 4, to like assignment 4 dot backup or something, just in case like you get like a significant portion of the way through your program and you don't know what's going on anymore, and it's just kind of a mess. And then you could go back to your backup and start over again. In addition to that, like create small chunks first, create portions that work before you do anything like that, or build it slowly, essentially. And that's what I'm doing right now. I'm building it slowly, building the individual components themselves. But we'll go ahead and do the outline staircase. So just like with the triangle, we're going to need 3 variables. Oh, and sorry, I never talked about this before. I should probably talk about that. So one of the, we'll come back. We'll get there. Don't worry about it. Okay. So one of the things we've talked about is, of course, you need to say the data type and the variable name. One of the things you can actually do is you can say data type variable name and then give it a number of variables that you want, just separated by a comma. So I could say this. I could take all of these down to one line. So that's completely equivalent to saying int I, int j, int diff. It just compartmentalizes a lot. So if anybody was wondering what was going on there, that's what was happening. So just keep that in mind. So finally we're getting there. Okay, so ij height. So we need to prompt for the height. Alright, so first loop is going to say I equals 0, I is less than height, and then plus plus I. So I think what's worth doing is we'll go ahead and we'll just print the staircase to start off with, and we'll come back and we'll print it correctly later. So then we say if our inner loop is for j equals 0, j is less than the outer index, which is I, and then we need to increment j. So we got that. Inside that loop, we need to print our stars. And after loop, we need to print a new line for each row. And we'll see where we're at. 1, 2, 3, 4. So off by 1, go back in there. What I need to do is change these less than or equals to, let's not change that one, let's change this one. But again, it's just a matter of tinkering around with it, trying to figure out what's going on. 1, 2, 3, 4, 5. There we go. Now we're on correctly. And while I'm at it, one of the things I forgot to do was read again after I had made that initial choice. So one of the things you had to do was read at the end of your loop. So you needed to say scanf. After you've processed all the options, you say choice again. And you need to print the menu again, but I'll leave that off for now. So we have our basic printing there. So essentially we need to test a bunch of different conditions here. So the way we can do that, I'll do it the compact way first, and then I'll split it up into maybe a more understandable way later. So we need to see if the inner index equals 0. So remember that this is going to, here, I'll do this. So let's look at this. So let's say we have a triangle like this. So when we're looking at I, so we'll look at our outer index first. So this is what we're looking at, outer index, I. So when we're looking at this, our outer index is going to look something like this. For each of these stars, when we're printing that star, this is what our outer index is going to look like. So that's looking at I. So let's look at what our inner index looks like. So our inner index here would be 0, here would be 0, 1, here would be 0, 1, 2. So given those numbers, to print the left side, all we have to do is see if our inner index, if j is equal to 0. So that's our first condition. So these stars right here match up with these zeros right here. Okay, so we'll go back over and we will test to see if we have the left side. So if j equals 0. So we're going to test if our inner index equals 0. Because remember that this entire side here, our inner index is going to be at 0 regardless of how big it is. The left side is always going to be 0. Okay. Actually, I'll do it the expanded way first. That makes more sense. And we need to make sure we use else-if statements. Otherwise, we're going to test multiple conditions, and it just might not make sense. So the second thing we need to do is test if the inner index plus 1 equals the outer index. So looking at this again, so let's expand this a little bit so I can get a little bit more power here. Okay. So I think my numbering isn't quite on. The problem is we're using a less than or equals here. And so that means that we're going to be running one less time. Doesn't matter, but so just off of the logic right here, we can say inner index plus 1 equals outer index. So we have our inner index, which is j, so j plus 1 equals outer index, which is I. So before I do anything else, what I'm going to go ahead and do is just show you what that first statement does. So I need to print some spaces. Or what we'll do is we will use, we'll print spaces as @ signs right now. So you can see that the spaces are actually there. I did left off an ampersand on my choice there. So we can see that our loop should be printing spaces there. We got 1, 2, 3, 4, 5. So we got the left side. So go back in. This one equals I. Then we're also going to print star. Run that again. And hopefully I'm doing this right. Not quite, unfortunately. Well, something's happening. Oh, it's because I'm printing spaces, that's why. Okay, to get this to line up, I have to print it a little bit differently. I have to print an ampersand or @ sign with a space. Okay, that's lining up closer now. We'll come back and figure out why it's doing what it's doing later. So we do that. We say inner index +1 equals outer index. So we test that condition. And finally, we need to see if the outer index equals height. So what I say by that, we need to have a final condition. So outer index is I equals height. And that's why my numbering's off here. I need to change that to equal. I did put the wrong less than or equal sign in there. That's why I'm off. Okay. And then finally we'll print another star. And hopefully if everything went according to plan, which of course it didn't, we would get there. So I think what I did was I printed single spaces. So I'll go back and I'll try this again. Again, this tricky assignment, it takes a while to get there. You have to tinker around with it quite a bit. Nope, still not there. So what am I doing wrong here? Inner index +1 equals outer index. So we got the left side, that's right. So let's, from the way I was numbering things over in my example, I think that's more correct. Or not. Still not right. Yeah, this is it, that's it, okay. Double spaces, not single spaces. There we go. Nope, still, did I not compile it again? Okay, I didn't compile it again. I'm thinking this is, I'm pretty sure this is right this time. No, okay. Okay. Soon, I'll figure it out soon. Let's go back, let's change this to -1 again. Okay, oh, here we go. That's because I'm not printing double space. Okay. Change things around again, print single instead of double. Change that back to -1, or change it back to equals, I guess. And it's still, did I not recompile it? Took off all my stars there. I took off all my spaces. Alright, well, I'm going to go look at my old code and just figure out how I did it last time. Less than height. because this code works right here. I promise this code actually works. J equals 0. J plus 1 equals I equals height. So this is the compact way of doing it. So you combine all the conditions using ORs. You could also do the else ifs. That works perfectly fine too. Ooh, I had my star on the left. Maybe that's all I needed to do. Okay, well, I'm ready to give up. Are you ready to give up too? Do you want me to try? I can keep trying, but yeah. If I took any points off for the triangle and you want them back or something like that, just let me know. It's fine. What? Yeah, So I mean, you could structure it either way. You could structure it like this with the else if statements like that, or you could structure it with the or like this. So J inner index, so J plus 1 equals I, or so outer index equals height, I equals height. I don't think that should change anything. Maybe it will, maybe it won't. Yeah, I don't know what's going on right now. It seems to me what's happening here is for some reason, did I put that inside an else? Did I put my spaces inside an else? I wonder. No. Oh, here we go. Here we go. So here's the problem. So this needs to be inside an else. That's what we need to do. So since that wasn't inside an else, we're going to print spaces unconditionally every single time I run the loop. That's why things are broken right now. Okay, here we go. Here we go. Here we go. Here we go. Hey, now it's a triangle, so it's getting closer. Here we go. Here we go. Now I think what I want to do is go back, and I want to change this to actually be equal instead of plus equals 1. You could change the there's a triangle. I made a triangle in class, guys. We are good to go. I can't believe I really can't believe you actually counted. I was just going to hope. Okay, so we'll change this to be, what are we going to change? We're going to change height, and we'll change this. We'll change this instead. All right, so we'll change it to be less than. Now we'll also have to go back and we'll have to change this to be minus 1. Pretty sure plus 1. There we go. Now we're full. It should be fully in line with the logic that I put forward there. There you go. There's your triangle. In line with the logic. It just takes a lot of work to figure out what all the minor details are, especially if you're not necessarily keeping track of what's going on. So the problem was essentially if it's all about the numbering, and the numbering's tricky, and it's hard to get it right on the fly, so kind of just got to sit down and hammer it out, but there you go. Yeah, there's a triangle. Are we kind of in line, or makes more sense, I guess? That's honestly the trickiest one, just because there's so many different conditions that you have to write. So I don't think I honestly took any. Did I take anybody's points off for the triangle? I don't think I really did I? Yes, no. Anybody can confirm? No, yes. Okay. It was a hard one. If you gave it a try, I should have given you points. If I didn't by chance, then ask me back or ask me again. I'll give you a few back or something. As long as you gave it a shot, like that's all I really ask for that one. So, any more questions? Anyone else want me to talk about anything for this? Anyone want me to spend another 30 minutes on one problem? Okay. So, if not, don't have a lot of time left today. so we won't have an in-class assignment. I was kind of planning on it, but that's fine. But I did want to talk really briefly about functions, so that's going to be what we're reading about in Chapter 5. We're going to talk more about on Thursday, but I just wanted to give you a real brief overview, kind of get you acquainted with the subject matter. So, one of the things you probably ran into with Assignment 4 was having just that jumbled mess of code that was kind of just clogging everything up. You probably were getting to about 100, 200 lines of code, and it was just becoming unmanageable and things like that. So one of the things that we can do, we can actually break things up into smaller pieces of code, and we call those smaller pieces of code functions. So we would say something like void my function. And it sets up just the same as main. For right now, you just say void and the function name, give it 2 parentheses, and then give it an open bracket and closing bracket. So inside that, we can put as many statements as we want to. So we can say hello if we wanted to. For right now, that's all we're going to do. Well, actually, let's say hello and then say today is Tuesday. So that's our little function. So inside our main, what we can do is we can call that function. We can say my function. And what will happen is as soon as we see this my function right here, what we're going to do is jump up to the top of this code block, and we're going to start executing statements inside that function. So we need a return 0 to get rid of that warning, and we'll run that. So when we call my function, so let's go through this line by line. So we start here, we go to this line, here. Numbers, one moment please. I don't remember all this stuff off the fly. Okay. Now we got some line numbers. So start line 10 here in our main. That's always where we start, at the top of our main function right here. The main itself is a function which is called by the system when the program is initially loaded. We'll talk more about that later. So we start at 10 here. We go to 11. So once we see my function, we're going to go all the way up, start executing right here at 4, execute the statement 5, execute the statement 6. When we're finished executing, we return back to line 11, and then we finally execute this statement, return 0. So just to show that a little bit more, we'll say entering function, and we will say exiting function afterwards. So there we go, entering, then we are actually inside of the function, and then we have exited. So again, so line 11, go to line 12, then we jump up to 4, so execute 5, execute 6, hit 7, we hit the end of our function, and then we continue back at 13, print that, go to 14, print that. So let's go back and let's look at our assignment 4. So one of the things we can do is we can take this code and we can break it up into functions. So let's say we have a void sum. So what we can do is you can take all of our code right here, you can just take that and put it over here. Not there, here. Yeah. Okay. So now instead of having that code there, we can say sum, and it will jump set number. So once we reach line 30 here, once the user has inputted 1, what's going to happen is we're going to go from line 30, and then we're going to go up to line 4, and then start executing statements inside here, just like before. So essentially, at the very basic level, you can take code that you have already somewhere, and just at the very, very basic level, and this isn't meant to be, we'll talk again more about what's actually happening here, but when we do something like this, think of this just as being an alias for all of this code right here. So all of this code, at a very, very basic level, this isn't actually how it works, but think of it this way. All of this code that's executed right here could be right here. It very well could be right there. It's not. It's up there in our sum function. It's broken up, so we see just the small components of it right there. So we can continue to do the same with, let's do this with our, this is our triangle right here. So we'll take all of that, and we'll move it up here. And then we will need to say try where we left off. So I'll just confirm this actually works. We recompile it, say sum, 10, 20, 30, works just fine. And then we're back to that while loop in that very last prompt. There should be a menu here since I exited, but that's fine. So just think of that. This right there is an alias for the code up there. So just same as before. So let's say the user inputs 2. What's going to happen is we get to line 60 here. We see that try function call. We're going to jump up to this function, start executing at 15, execute through all of these statements just like we normally would, executing the loops, so on and so forth. And then when we get to 39 right here, once we reach the end of that block of code, that function, what's going to happen is we're going to come back down here to line 60, and we're going to continue executing. So what that means in this case, we're going to exit this else if block, and then we're going to execute this scanf at the very bottom. So yeah, that's all I want to talk about right now. So for your use, if I was in Nano, with Nano, you can move code around just like I was doing by, let's go down here. Fortunately, there's quite a bit of code. Here, I'll maximize this again. If I can. So you can move code around in Nano with Control K and Control U. So there we are. So we're on this line right here. So we can say, let's say we said Control K, KK 3 times, and then we said Control U. It would paste that code just like that. So in the computer science world, we refer to the data structure powering this as a stack. So as many times as you push Control K, it's just going to pile the lines up on top of each other, and so on and so forth. And then when you push Control U, it's going to take exactly what you took, and it's going to paste it out. So what we can do is take this entire thing, we'll say Control K a bunch of times, and then we're going to go up here, and we're going to write a new function. So we'd say void stare, opening bracket, and then we can say Control U, and it'll just drop it all in there. Now, of course, it won't be formatted that well, but that's no problem. If we just exit out, we can say format assignment 4, open it back up again, and we're good to go because it moved all of our, well, and we're good to go because it moved all of our stuff around. So if you're working in Nano, just use Control K, Control U to move that around. Finally, to get that to work, we just do it like we've done before, and we say stare. I think our function name was stare. I don't remember for sure. Stare, stairs, stare. Yes. And there you go. So that was the basics of functions. So we can continue on and do a whole bunch more stuff with functions, but we'll talk more about that on Thursday. Going forward from this point, one of the things I'll probably have you do, just for the fun of it. It's kind of just, well, it's not really fun. It's actually just busy work. Sorry. What I'm going to have you do is take your assignment 4 and functionalize it like this. So you're going to break it up into these little components. So your main is very contained, and you have all of the rest of your code somewhere else. Just so you have some practice working with functions, seeing where things go. Moving forward from this point, you might have noticed that I'll just cover a couple of things. We'll cover more in depth on Thursday, since we have a few minutes. You might have noticed that main has this int right here. So what that means is this main function returns an integer. So we can return different data types from our functions. So if I was to say, let's look at sum int. Let's say we wanted to actually return the value from that function. So let's say return sum. So when we say void, all that means is there's no return value. So nothing's returned from the function. We just execute all the statements inside of it, and then we stop. Or we continue executing wherever that function was called from. So if we said return sum, what we can do is we can actually have a variable, and we can store the result from that function in the variable. So one of the things we've used the rand function a lot. So this isn't the right rand function, but what we can do is kind of I can show what this would do. So let's say there was a rand function, and there's obviously a bunch of math going on to figure out what the actual number is, but we could say something like return 10 times 30 times whatever, and it would return a number or something like that. So when we're using the rand function, that's what's happening. It's generating some sort of number. Obviously, that's not the number it's generating. It's based on the previous numbers that are generated in the pseudo-random sequence, but that's what's happening. So we can return numbers from functions. And we can also pass values into functions, but I'm not going to talk about that today. So if you have any questions, feel free to stick around after class. We can talk about anything else. But that's all I have for you today. So please try and read Chapter 5, User-Defined Functions, for Thursday. It'll really help out during our discussion and working on the in-class assignment. So that's it.